Okay, we're going to go ahead and continue to work with logs, but we're going to go into a new idea of natural logarithms in log base e. Now, looking at your calculator, which should be similar to this, you should know by this point that your normal log button is here. But there's an ln button here, which is referred to when you are using that button for when you're dealing with a natural log. So if you wanted natural log of 6, you'd hit that ln button, you type in 6, and you get your answer. Also make note that your second function ln is e to a power. We're going to be dealing with that too today. Now, here is an approximation of e. It actually goes on forever, but it shows up a lot in mathematics, so just beware of that. So because this number kept showing up over and over again, they gave it a special name of e. It's really the second most common irrational number in mathematics that shows up next to the number pi. So one of the ways it shows up is in compound interest when things are compounded continuously. So if it's compounded continuously, then you're going to use e. Now, a logarithm that has a base of e, which is what we would have right here, you can say log base e right here is just this, ln. Okay, so an ln, or a natural log, is really a log, so that means all the properties of logarithms would apply to natural logs. Now just know that e and ln undo each other. So here you have an ln of e to a power. They undo each other, so it's going to leave you with just x. Or here, your e and your ln undo each other, so it's going to leave you with just x. So for clarification, what type of logs would we use down below? Here you're dealing with an e, so you'd want to use a natural log. Here you are dealing with a 10, so you'd want to use a common log because a common log is log base 10. Over here on the right, we are dealing, I have no idea why that strange line came in there. We're dealing with a 5. Doesn't make a difference. You could use natural or you could use common. Either one will work. But if you were dealing with like the far left with an e, definitely use a natural log. If you're dealing with the middle one of 10 to the power, definitely use a common log. If you're using something other than your base of e or base of 10, it doesn't make a difference. So we're going to go ahead and take a look at this, and we're going to try to solve these. Now remember, natural log is really just a normal log with just base e. So we have a log minus a log. Remember, a log minus a log, you go ahead and divide what's afterwards, and what was the first thing goes on top, what was the second thing goes on the bottom. And so in this case, that fraction simplifies. The 2's drop, you get an x squared is equal to 2. Now, remember, natural log is really log base e. So we can now go from our log form to the exponential form. So we can take our base of e and swing it over, and it hits that 2 up as the exponent, and then it'll be equal to what's after your log. Then to finish solving it for x, we're going to go ahead and take the square root of both sides. And remember, when you take the square root, it's plus or minus. You'd have the square root then of an e squared. Well, hopefully you remember from the last quarter that the square root undoes your squaring, so it's really plus or minus e. But note, our directions say to the nearest 10 thousandths. So if we do that, we could type that into your calculator. So because you're dealing with e, remember you have to go second ln, gives you an e, and it might give you something like this, or it might give you something like this, and then you just type in 1 and then hit enter. When you do that, typing that into your calculator, you would get plus or minus 2.7182. Now, keep in mind that whatever's after your log always has to be positive. We started out with logs, so we'd have to go ahead and check this answer. When we check this answer, and we're putting it in here because that's our only input, whether you put a positive in and square it or put a negative in and square it, it ends up being a positive number. So yes, both of these plus and minuses will end up working. So over here we have a log plus a log. So remember, using our properties of logarithms, we can go ahead and write it as 1 log and multiply what's afterwards. So we can take our 4x times our 9. By the way, I'm going to just write that as a 36x squared. Now remember, your ln is really log base e is equal to our 4. So then we can go ahead and take our 36x squared. When we use our definition of a logarithm, take our e, swing it over, hit the 4 up as the exponent. Then we're going to finish solving it for x, so we'd have to get rid of timesing by 36, so divide both sides by 36. Get x squared is equal to an e to the 4th over 36. So then you'd have to do the square root. Remember, you'd be plus or minus the square root of the top over the square root of the bottom. So we would get x to be plus or minus the square root of the bottom is a 6. Square root of the top is e squared. So you could type that into your handy-dandy calculator. So go second ln, which is your e to a power button, hit 2, close your parenthesis, then hit divide by 6. When you do that, you get approximately plus or minus, remember it's plus or minus because we did a square root, 1.2315. And then, because we started out with variables after log, you have to check it into your original. If we take a positive or a negative and plug it back in here to the original, because of the squaring, whether it's positive or negative, it's going to make it positive, which is good. So they'll both end up working down here. So when we look here, we have our part with the exponent on one side by itself, so we can go ahead and use our definition of a logarithm. We can go log of our base of e of our 87 is equal to x. But remember, log base e we can write as just a natural log. So it's really natural log of 87 is equal to x. Our variable's on one side all by itself, so we can just type this in. So you want to hit your natural log button, and then go 87, hit enter, and then you get about 4.4659 is equal to x. Looking at problem 41, the top right one here, you have your part with the exponent on one side by itself, so you can just use your definition of the logarithm. We can go log of our base of e of our 93 is equal to our exponent. Now remember that log base e we can just write as a natural log of our 93 is equal to our x plus 4. So to get x totally by itself, we'd have to go ahead and subtract a 4 from both sides. So we really get natural log of 93 with a minus 4 is equal to x. And that's your calculator ready form, so you can just type it into your calculator just as you see it. Hit your ln button, natural log, then type in 93, close your parenthesis, then minus 4, and you should get 0.5326. So looking at the next problem, remember you got to get the part with the exponent on it on one side by itself. So that means you got to get rid of that 7. So to undo timesing by 7, you'd want to go ahead and divide both sides by 7. Now, when you're looking at the right side, 38 divided by 7 doesn't end up being a nice neat number, so just leave it as a 38 divided by 7. So now that we have the part with the exponent on one side all by itself, use your definition of a logarithm, which would be log base e of that fraction equals your n minus 1. Now remember, log base e, once again, is another name for natural log. So I'm going to go natural log of that fraction. We don't have to work out that fraction. We can just leave it like that, is equal to an n minus 1. Well, to get n by itself, we'd have to add a 1 to both sides. So our answer is going to be natural log of 38 divided by 7 with a plus 1 is equal to n. Then we can type it into our calculator all at once, just as we see it. We can go natural log 38 divide 7, close your parenthesis, plus 1, typing that into your handy-dandy calculator, and you get your 2.6917 is equal to n. Looking at our next problem here, you will notice that we have a plus 10, and we have a multiply by the 5.7. But you need to get the part with the exponent by itself. So hopefully you remember from solving other equations, you got to undo addition first. And then we'd have to undo our multiplication. Now 41 over 5.7 doesn't work out nice, so we'll just leave it like that. Use our got the part with the exponent by itself, so use your definition of a logarithm. And then we can just write this down. Now remember, log base e is natural log. And to get r by itself, you'd have to undo the minus 6, so we're going to just go ahead and add 6 to both sides. And then we can type it into our calculator just as we see it. Natural log 41, divide by 5.7, close your parenthesis, plus 6, and you get 7.9731 is equal to r. So now we have a word problem we're going to go ahead and look at. So go ahead and read through it, and then we'll talk about it. So here's your formula for when you're dealing with compounded continuously. If it's compounded continuously, you're going to be using this formula here, where P is your initial amount you start with, R is your interest rate, but as a decimal, T is your time, and then A, it's the amount that you're ending up with. So I'm going to just start writing some things down. P is what you're starting out with, and now it says you deposited this, so that's going to be your initial amount. Now R is your interest rate, R, and then we have to have that change to a decimal, so move it over 2 spots. Now it says how long, well, that's going to be our time, for your money to double. So we put in $300. Well, if you double that, it means you'd be ending up with $600. So now all we're going to go ahead to do is to solve it. So you got to get the part with the exponent by itself. So you'd have to divide both sides by 300. You get 2 is equal to your e to 0.025t. It's e to a power, so use your definition of a logarithm. You get log of your base of e of 2 is equal to that decimal in front of your t. Remember that log base e is natural log, so it'd be natural log of 2. And then to get rid of that timesing, you have to go ahead and divide. And that's your calculator ready form. You can just type it into your handy dandy calculator and you get 27.726. And then we have to look at what's the context of our time. It does say up here that t for our time is in years, so you'd have to put years by it. Down below, it says compounded continuously, so you have to use the same formula again. It says you are depositing $250. That's what you start out with. It says your interest rate is 2%, so your R is 0.02. And it's telling you that we're doing it for 5 years, so that means T is 5. We're trying to figure out how much money we're going to end up with. So for the most part, you can just go ahead, since your y is on one side by itself, type it in just as you see it. Go 250 times E. Remember, E is your second ln. It should give you an open parenthesis. Then put 0.02 times by 5, close your parenthesis, and you get 276.29. Now, remember, we're dealing with money here, and we're dealing with dollars, so you have to put a dollar sign. And also with money, you always have to go to the nearest cent. So that's what we would get.